Hello and welcome to the second episode of our video series about decentralized identifiers. Today we talk about creating deeds, and this is really the part that makes deeds so special compared to other technologies because it goes straight to the heart of the question of what is the concrete act by which a digital identity is created and linked to a physical identity. You can think of creating deeds as a technical process through which ideas such as self-sovereignty and independent existence materialize. Unlike most other types of digital identifiers, deeds are designed to work without central authorities and intermediaries. And this is also reflected in the language that we like to use. For example, we don't say that deeds are issued by an authority to a subject, but instead we say that deeds are independently generated by a controller. And this is also a really important point that when a deed is created, usually the controller does that by generating cryptographic key pairs and performing a few other steps. And there are some details to consider. For example, the keys that are used to create the deed may or may not appear in the deed document. And the controller who generates those keys may or may not be the same entity as the subject that the deed refers to. But what's important here is to understand that there is this built-in concept of control when it comes to deeds, and that whoever controls the deed also was the one that created the deed. In terms of architecture, creating deeds is a little bit similar as resolving deeds, insofar as there's not a single concrete architecture or a single protocol, but instead creating deeds is something like an abstract process that has certain inputs, certain outputs, and certain states, but it can be implemented and realized in different ways, and this mostly depends on the deed method that is being used, right? Sometimes there are blockchains or web servers or domain names or peer-to-peer networks, or sometimes entirely local processes that are used for creating the deed. So there's a lot of variety. But one thing where creating deeds is really different from resolving deeds is that it's usually a more complex process where there may be multiple steps involved as opposed to just a single operation. This could mean, for example, that for certain deed methods you need to interact with an onboarding service or a transaction endorser. You may have to pay for transactions, or you may have to agree to some legal terms. So there are potentially different steps. Sometimes you may have to wait until the deed is finally created. So this kind of interaction and multiple steps, this has to be reflected in an interface, and this makes it a bit more complex than resolving deeds. And then, of course, the very interesting question is that of key management. So as we said before, creating a deed involves usually generating key pairs, and that is typically done with some kind of wallet. But there is quite a bit of variety when it comes to the architecture of those wallets and how exactly wallets interact with other components that are needed for creating the deed. So let's look at that in a bit more detail, what this architecture looks like. So when describing this process of creating deeds, we can essentially use a similar model as we had with deed resolution, using three different components. One of the components is a client. This is essentially an application or a service that wishes to create a new deed. Then we can imagine a registrar component. This is the one that's able to actually perform the create and also update and deactivate operations for a deed. And then, of course, just like with deed resolution, we have the verifiable data registry. This is where the deeds exist and where they are created. When looking at this, it's very important once again to point out that this is an abstract architecture that can be implemented and deployed in different ways, especially the component in the middle that we call a registrar. It's important to understand that this is not meant to be a separate entity in a legal or business sense, but all of these are logical components. There's a logical separation of concerns, and these could be interacting with each other in an entirely local way or using remote APIs or some combinations. So there are different ways of actually instantiating this abstract model. In terms of flows and inputs and outputs, the client invokes the registrar component, and it passes a DID method that it wants to use for creating a DID. It passes a DID document, which in many cases may be an incomplete DID document. So this is important to understand, that the DID document that you pass in initially when you want to create a DID is not necessarily the complete DID document that you get at the end. Specifically, the DID itself is usually not something that you can arbitrarily pick, but it's something that will only be decided and determined at the end of the process. In addition to that, the client also passes in options to the process for controlling certain aspects of where and how the DID is created. And in some cases, depending on the exact flow and depending on the DID method, the client may also pass certain secrets to the registrar component, for example, access tokens or other secret values. Then the registrar takes care of all the DID method specific operations, constructing payloads, interacting with the verifiable data registry, and it writes the DID document contents to that verifiable data registry. The result of the process is the DID and a state, and both of these pieces of information are passed back to the client, the DID, the state, additionally some metadata about the process that just happened. And why is there a state? So this is important to understand, that creating DID sometimes involves multiple steps, right? So it's not like DID resolution where there's just one round trip or one request and response, but the client may have to interact with the registrar multiple times. And the current state of the DID creation process is being tracked by this registrar. Sometimes a client may have to wait until a DID is fully created or anchored on a ledger. Sometimes the client may have to perform some actions before the registrar can proceed with the process. So we model this using a state component, and to keep track of this state between a client and a registrar, we introduce a field called job ID, which is passed back and forth. The most important aspect of all of this is key management. So when a DID is created, typically the controller generates key pairs, which are used for creating and writing the DID. In this architecture, we envision different ways where in the picture these keys and key operations can happen. They take place in a wallet component typically, and we believe that this wallet where the key operations take place could be part of the registrar component itself. So in this case, the DID operations and the key operations happen in the same component. We call that internal secret mode. But there's also a way where a wallet could be yet another external component that the registrar interacts with whenever key operations need to be performed. And then what we think is the preferred mode is what we call client managed secret mode. This means that a wallet exists here on the client side. All the key operations take place here on the client side, and all the DID operations are performed by the registrar. But today we'll focus on internal secret mode because that's the simplest and easiest to explain the process. So let's go ahead and create some DIDs. To demonstrate this, we will once again use our platform godidi.com, which includes a universal registrar service for creating DIDs. In order to create a DID, I first select a DID method such as did_indi. Then I can fill in the DID document for the new DID that I want to create. For example, I could add a service endpoint here to the DID document. Let's say a didcom service endpoint with an example identifier and an example URL value. I add that to the DID document, and then I can select various options for the operation. In this case, for did_indi, I can specify which network I want to use. I will now use a test network that we are running ourselves, but this could also be sovereign or in DCO or ID union or any other network within the did_indi method. And then I invoke the universal registrar operation for creating the DID. And the universal registrar returns a response that I can look at here on the other tab. this response basically says that the state of the operation is finished and that a new did has been created. And I can do the same with any other did method, such as did_epsi. It's the same process. I can fill in a did document with various options. In this case, for did_epsi, I also need an onboarding token, which can be passed here as a secret. But otherwise, the interface for creating the did is exactly the same as before. Universal registrar returns a response, and here again is the new did with the state finished. Same functionality can also be invoked using an API with a client, such as a local SDK or command line tool. You can call the universal registrar endpoint, passing in a did method, such as did_key in this case, and I pass the same input fields, including a did document, options, and secrets. For the did_key method, one of the options is the key type I want to use. Then I call the API, and it returns again a new did with the state finished. I can do the same with yet another did method, like did_pkh. In this case, the options are a bit different. I can specify a network where I want the did_pkh to be created, and then it's the same process. I go ahead, invoke the API, and it returns a response with the state finished. And I will just show one more example, this time using the did_ion method. And it's again basically the same interface. However, with did_ion, something slightly different happens after I select the options and the inputs and the did document. And then when it returns a response, the state is not finished, but instead the state is wait. This is because for did_ion and some other did methods, it actually takes a bit of time until the did is properly anchored and created. For this reason, there's a state and a so-called job ID field, which basically keeps track of the state of the did creation process. It means that you can invoke the same API several times until the did is finally created, and then it will switch to a state of finished. And all of what you've just seen is pretty much did method independent. The client does not have to implement anything that is did method specific, except for a few options. But in general, this is a generic universal interface that works the same way across different did methods. From a key management perspective, what I showed was relatively simple, because both the key operations and the did operations are handled by the universal registrar service, which includes a hosted wallet. This is what we call internal secret mode. Okay, so we just created a few dids across different did methods and networks, and I know what you're all thinking. If you use a remote service for creating your dids and the associated keys, doesn't that completely contradict the idea of decentralization and privacy? And you're absolutely right about that. And that's why next time we will take a closer look at client-managed secret mode, which more cleanly separates the key operations and the did operations and is overall better for decentralization and privacy. That's it. Thank you and goodbye.